Section 4.6 is about using trapezoids to approximate the area underneath the curve. Okay, so the book talks a little bit about what they call the trapezoidal rule. I don't want you to worry about the trapezoidal rule. I want you to think about this is just another way for us to take an area underneath the curve and break it up into geometric shapes that we can calculate the areas of, and that will give us an estimate of the area underneath a given curve. All right, we've been using rectangles in the past. We had upper sums and lower sums, and we talked about midpoints. And then we talked about Riemann sums, where we made those rectangles more and more narrow, and as we took the limit as the number of those rectangles approached infinity, we got the definite integral. Here is just another way for us to estimate the area underneath the curve. This time, instead of using rectangles, we're using trapezoids, and you can see that usually, since we don't have to have this upper part here as we would for a rectangular sum, we can just go right from that point to that point, cut straight across. It's still an estimate because we're estimating that curve as a straight line, but we get a better estimate. In fact, we get what is in fact the average of the upper sum and the lower sum. So it gives us a better estimate of what's under the curve, but again, it's just another way for us to get an estimate. We're going to estimate the area, the total area underneath that curve, by adding up the areas of those individual trapezoids. Note here that the trapezoids don't always have to be uniform in width. They often are in textbook examples, but they don't have to be. We calculate the area of that trapezoid. We know B1, B2, and the height. Notice that the trapezoids are kind of laying on their side. We got B1, B2, and the height. We got B1, B2, and the height. We calculate the area of each one of those trapezoids, and we add them up. All right, so the definite integral represents the area between the curve and the x-axis, as long as the function is continuous and non-negative. So using trapezoids just gives us another way to approximate the definite integral. That's the whole concept here today.